Anti-collision is a product unlike other product in the market. It's not just a software that allows the drone to detect an object or avoid it. It's also not requiring any additional hardware, like most software or product in the market that will need you to apply additional hardware to the drone, which will break the drone balance and add more weight, causing the battery flight time to go down. So our project mainly used a drone called Tello. This is also a drone that is provided by DJI, and also it allowed coding. And that's the main reason that we had used Python, and we also had used Tello as the platform, as the base platform of our project. So basically, we use something called GUI. So since our drone does not need a controller to control over the drone, so therefore it can automatically fly by itself. Therefore, the only control need for entering this software is to take off and to tell when it's fine to land. And on the bottom right, this is a little sample of how the drone is processing its object. So the green line means clear and blue means a little object to the left. So this is some code that was in part of my project. So on the left one, it says receive command and open video feed. So one good part about my drone is that it can tell you, like it can almost tell you where it's at. It will provide a positive video feed to you. So you cannot just control the drone, but you can also know where the drone is going. And also on the left side, there's also a little set of code that will receive command and process the video. And also it will share it to your screen to make sure you have a positive video feed. And on the right side, it can tell it's a maneuver command, which it will tell the drone to go left, right, front, or back. And all of our code is demanded by degrees, which means that the drone will calculate the degrees due to its GPS system. Therefore, it will have a very sharp and precise turn and maneuver every time. So this is a demo video from my drone, which I'm about to show you right now. So as you guys can see, after the drone has took off, the video feed on the left side will automatically pop up. It will continue to proceed forward until it detects some object and it had turned right. However, in this case, there is still some object in the right. It turned right again to avoid those objects. So that was just a little demo for how the drone really works. So some of the challenge that I have to overcome is to choose a platform that will work into a drone. So as most of you guys know, drone these days will need a controller or some kind of a controlled force that to control the drone. It was very hard for us at first to find a drone that can be commanded by code, and it does not need any Wi-Fi service. And second is to get a positive drone video feed. Since we have to let the drone process the video feed firsthand, it was very hard for us to get a positive video feed without little delay or a lag due to the FPS limits. So some of the future developing goals will be a longer flight time. Since our data right now kind of kills the battery really quickly, the drone originally have a 15-minute of flight time. With our software added to the drone, it will have a 12-minute flight time. However, this is not enough flight time for some scenarios. So we want to come up a code in the future that will have a less battery energy power needed to make the drone have a bigger flight time. And second is a stronger drone motor. So a stronger drone motor will have more power on the drone, allowing to carry any accessories that the user might need. And third, if the drone have an error pop up in the data, or if there's an emergency, the drone will automatically land itself and detect the object below the drone. If it's a solid place or a good amount of space for the drone to land, it will automatically land the ground and kill power. And last but not least, a better feedback. since our drone only have a 30 frame per second camera, therefore, we will have an upgrade to the drone, make it 60 frames per second. This will allow the drone to process a much smoother video feedback from the drone, and also allowing the controller to view the drone better without little lag or delay. And thank you. Some of the contact information is up on the screen. And thank you for watching my presentation on ET collision.
Steven, thank you very much for this presentation. It's really good. Now let's head over to the question and answer section. Does anyone in the audience want to ask questions about this project? Are there any ideas anyone want to add to the conversation? If not, so then I can be asking. So there's one thing I wonders when I watch the presentation is that what do you think is like the hardest part to do throughout the whole entire process of this project building?
Well, like I said in the presentation, the most hardest point was finding a drone that allowed us to apply data and coding platform to the drone. And the second one is to have a positive video feed on computer.
That's really good. And then how about, let's say, if you fix all those challenges and then actually works in the future to finish all your future developments, what are some like real world application of your project? Like, what do you think it's a field that we can use your project the most?
Well, one of the biggest reason that I choose DJI because, like, in my perspective, I think they're the biggest drone company in the world. Like, a lot of my friends and a lot of like professional like movie shooting or professional photography, they had used DJI drone over a long time, which means that I can apply this drone with my data anytime and without any hardware added. So it's more like a safe shell for them while they're working like their views or they're working on the camera settings. They don't have to worry about the drone crashing. That's like one of the biggest goal and perspective for me.
Nice. So you have a long-term future plan over there. That's really good. Anyone in the audience want to ask something? I think that this is a really interesting project. Did you work on this like on your own or with a team?
I worked it on by my own since like it's very in a special like area, like not a lot of people get like drone times and know the drone. So like I find out working by myself will be easier.
Anyone want to add any additional questions? Okay. So if no one want to ask any more questions, I think this could be probably like the end of our meeting. So thank you all for coming. And then it is definitely a good project to share today. If no one want to say anything, I will just stop the meeting right here. Okay.